In this video, the learner will determine the area of a regular polygon using its apothem. First, let's talk about a couple of terms. Remember that regular polygons are both equilateral and equiangular. So this would be a regular pentagon. And every polygon will have a radius. The radius is a segment that connects the center to the corner of a polygon. So we can have a radius from the center point here to that corner. We could draw a radius from the center to any of those corners, and it would be a radius of that pentagon. We also have another segment that we're going to be talking about, and it's called the apothem. The apothem is a segment from the center perpendicular to the side at its midpoint. So the apothem is perpendicular to the side at its midpoint, so therefore it cuts the side in half. So the apothem is the perpendicular bisector of the side. We could draw an apothem to each one of the sides from the center. First, we're going to take a look at regular triangles, which are equilateral triangles. We're going to label the pieces of this equilateral triangle. This piece right here, that segment, is called the side. The point here in the middle is called the center. The segment that connects the center to each corner is the radius. And the segment that connects the center perpendicular to the side is the apothem. Remember also that the apothem cuts the side in half. So we will have two equal pieces here. Because we know the angles inside an equilateral triangle are 60, we also can tell something about this right triangle here. The radius will actually bisect that angle and make a 30-degree angle here, which makes with our 90 a 60-degree angle at the center, making this right triangle here a 30, 60, 90. So we'll actually be using the 30, 60, 90 pattern to help us solve for certain pieces that we're going to be missing. The area formula for a regular polygon is area of a regular polygon is 1/2 times the perimeter times the apothem. So we will need to find the perimeter, which is adding all sides together, and the length of the apothem, which is that segment perpendicular to the side. So let's take a look at an equilateral triangle example. We want to find the area of this equilateral triangle. If we know it's equilateral, we know all the sides are the same, and we were given that one of the sides is 18. So we know all of the sides are 18. This solid segment here is the radius, and the dotted line is our apothem. The apothem cuts the side in half, therefore we know this piece here is 9, and this other piece here is 9. In order to solve for the apothem, we're going to use that 30, 60, 90 triangle and find the length of the apothem. We are given the side across from the 60, which is 9. We divide by √3 to get x, which will be 3√3. And then multiply by 2 to get our hypotenuse, which will be 6√3. Now knowing the pieces of that 30, 60, 90 triangle, we know across from the 30 is 3√3, across from the 90 is 6√3. The measure of our apothem is 3√3, and our perimeter is 54, which is 18, 18, and 18. Now that we have our apothem and perimeter, we can find the area. So area equals 1/2 times apothem times perimeter. So 1/2 times 3√3 times 54. Remember when multiplying with radicals, we multiply inside times inside, outside times outside. So everything outside gets multiplied together. We have 1/2 times 3 times 54, which gives us 81√3, and it's in square meters. This next example I want you to try. Now we're going to take a look at regular quadrilaterals. A regular quadrilateral is a quadrilateral that's both equiangular and equilateral. So in other words, a regular quadrilateral is a square. Again, we're going to label the pieces. This would be the side. The point will be the center. From the center to the corner is the radius. From the center, perpendicular to the side, is the apothem. And again, the apothem will cut the side in half. Because we know all of our angles are 90, the radius bisects that angle and makes a 45-degree angle, which makes that angle at the center also 45. So therefore we have a 45, 45, 90 triangle here. Because the apothem cuts that side in half, and because this is an isosceles right triangle, we know all three of those segments will be congruent. We're going to use our 45, 45, 90 triangle to help us solve for some missing pieces to be able to find the area, which will be 1/2 perimeter times the apothem. Anytime we have a regular polygon, this is the formula we'll use, 1/2 perimeter times apothem. Let's look at an example. In example 3, we want to find the area of the square. We are given the length of the radius, which is 5√2. In order to find the area, we need to find the apothem and the perimeter. So we're going to use our 45, 45, 90 triangle to be able to do that. We're given the hypotenuse, which is 5√2. Divide by √2 to be able to find x, which will be 5. So both of those segments will be 5. So in our triangle, these will be 5. Because the apothem cuts the side in half, this will also be 5. Therefore, our side lengths will be 10. Now we know our apothem is 5 units. Since we know our side lengths are 10, we know our perimeter will be 40 units. And we can plug those values in for our apothem and perimeter to find the area. So we'll have 1/2 times 5 times 40, which gives us 100 square centimeters. Here's the next example I want you to try. Next, we're going to take a look at regular hexagons. Again, we're going to start with labeling the pieces. We have the segments, which are called the sides, the point in the middle called the center, the segment from the center to the corners called the radii, and from the center perpendicular to the side will be the apothem. And again, that apothem will cut the side in half. Now, to find the angles here, remember we could use 180 times n minus 2 divided by n, and we would find that each of those angles is 120 degrees. But that radius cuts that angle in half, which makes a 60-degree angle at the corner. So with the 60 and the 90, we have a 30-degree angle at the center. So we are going to again be looking at using the 30, 60, 90 here to help us solve for pieces. I want you to go back and look at the equilateral triangle though and notice the difference. The 30 and the 60 are in different places from the equilateral triangle. We're going to be using the 30, 60, 90 to help us find those pieces to find the area. Taking a look at the example here, find the area of this regular hexagon. So we're given the side length of 26. We know it's regular, so we know the perimeter will just be 6 times 26, which is 156. Now we just need to find the apothem to be able to find the area. We know the apothem will cut the side length in half, which makes 2 lengths of 13 here. We also know we have a 60-degree angle at the corner, which makes this a 30, 60, 90. We know the piece across from the 30-degree angle is 13. Multiply the 13 times √3 to get 13 √3 for our 60 side. Multiply 13 times 2 to get our hypotenuse of 26. We now know our apothem across from the 60 is 13 root 3. That radius length is 26. We need the apothem, which is 13 root 3, for the area. So area is now 13 root 3 times 156 times 1/2. Multiply around the root 3 and have 1,114 root 3 square millimeters. I want you to try example 6, given the apothem. And then example 7. We're given the area and the length of the apothem, and we want to know what the length of each side will be.